Today we are going to learn about Python dictionaries. A dictionary is a collection that stores data in key-value pairs. Every key maps directly to a value, making it one of the most powerful and commonly used data structures in Python. A great way to understand dictionaries is through a real-world example. Imagine a phone book where you look up a name and it gives you a number. That name is the key, and the phone number is the value. That is exactly how a Python dictionary works. Now, let's look at the syntax. A dictionary is written using curly braces. Inside those braces, each key is followed by a colon, then its value. When you have more than one pair, you separate them with a comma. Let's zoom in on a single key-value pair. The key is the word name written as a string, and the value is the string Alice. The colon in between links them together, and this pattern is the foundation of every dictionary. Keys and values play very different roles. Keys must be unique and cannot be changed once set. Values can be anything, including strings, numbers, or even lists, and they can be updated at any time. Before adding any data, you can create an empty dictionary. The most common way is to just write a variable name, the equal sign, and a pair of curly braces with nothing inside. You can also use the dict function, which does the same thing. Let's start building a real dictionary. The first thing we write is the variable name student, followed by the equal sign and an open curly brace. That opening brace tells Python a dictionary is being defined. Next, we add our first key-value pair. The key is the string name, followed by a colon, then the value, which is the string Alice. The comma at the end is important because it signals that more pairs are on the way. Now we add a second pair. The key is age and the value is the number 21, with no quotes needed because it is an integer, not a string. After that, when we print the student dictionary, Python outputs all the key-value pairs wrapped in curly braces. Now that we have a dictionary, let's learn how to get data out of it. To access a value, you write the dictionary name followed by the key you want inside square brackets. This tells Python exactly which value to look up and return. We write the print function and pass in the dictionary access expression. Python sees student with the key name in square brackets, finds the value Alice stored there, and hands it off to print. Square brackets are used, not parentheses. When we run this, Python prints just the word Alice. Here is something important to know. If you try to access a key that does not exist in the dictionary, Python will throw a key error and stop your program. In this example, grade was never added, so accessing it causes a crash. The get method was built specifically to solve this problem. Instead of crashing on a missing key, it returns none by default, or any fallback value you choose. It is the safe alternative to square bracket access whenever you are not sure a key exists. The get method has two forms. The first takes just the key and returns none if it is missing. The second lets you provide a default value as a second argument, so instead of none, you get back something meaningful like the string unknown or the number 0. The first call uses name, which exists, so it returns Alice. The second uses grade with the fallback not available. Since grade is not in the dictionary, the fallback kicks in instead of throwing an error. The output shows Alice on the first line and not available on the second. Adding a new key-value pair is straightforward. You write the dictionary name, the new key in square brackets, then the equal sign, and the value you want to store. Python adds that entry to the dictionary instantly with no special method needed. Grade gets added to the student dictionary with the value A. Before this line, the dictionary had 2 pairs. After it runs, there are 3. The key grade is brand new, so Python creates it fresh rather than updating anything. After adding grade, Python now shows all 3 pairs. Updating a value uses the exact same syntax as adding one. Python checks if the key already exists. If it does, the value gets overwritten. If it doesn't, a brand new entry is created. The key is what makes the difference. The age key already exists with a value of 21, and this line reassigns it to 22. Python finds that key, replaces the old value, and moves on. The dictionary still has the same two keys, but the data stored under age has changed. The delete keyword permanently removes a key-value pair from a dictionary. You write delete followed by the dictionary name and the key in square brackets. Both the key and its value are removed with no way to undo the action. The delete keyword removes the age entry, both the key and its stored value, permanently from the dictionary. The output confirms only name remains. The pop method does two things at once. It removes a key-value pair, and it returns the value that was removed. This is the key difference from the delete keyword. Use pop when you need to capture the value one last time before it disappears from the dictionary. The pop method comes in two forms. Without a default, it removes and returns the value but crashes with a key error if the key is missing. With a default value as the second argument, it returns that fallback instead of crashing, which is much safer. Pop removes age from the dictionary and returns its value 21, which gets stored in the variable removed. The first output line shows 21, and the second shows the dictionary now only contains name. The in keyword lets you safely check if a key exists before doing anything with it. Write the key, then the dictionary name. Python returns either true or false with no crash, no error, just a clean Boolean result you can act on. Checking name against student returns true because that key exists. Checking grade returns false because we never added it. Both checks run safely without any risk of a key error, and it always gives a clean Boolean answer. Two important rules govern what can be a key. First, every key must be unique. Adding the same key twice silently overwrites the first value. Second, keys must be immutable, meaning they cannot change. Strings and numbers make reliable keys because they cannot be changed after creation. The keys method gives you a view of every key in a dictionary. You can use it to see what labels exist, loop through them one by one, or wrap the result in the list function to get a plain Python list. It only returns keys, never values. The keys method on the student dictionary returns a dict keys object containing name and age, the labels only, with no values included. You can loop over this object or convert it with the list function to get a plain Python list. The values method is the mirror of the keys method. Instead of labels, it gives you all the stored data. Invoking the values method and printing the result gives back a dict values object containing Alice and 21, the stored data with no labels attached. A common use is checking whether a specific value exists anywhere in the dictionary. The items method is the most complete view of a dictionary. It returns every key-value pair as a tuple, with the key first and the value second. This makes it the go-to method whenever you need to work with both pieces of data at the same time. Invoking the items method and printing the result gives back every pair as a tuple. Name bundles with Alice and age bundles with 21. The method takes no arguments, and the result is a dict items object ready to be looped over or converted. There are three ways to loop a dictionary. You can loop keys only, values only, or both at once. The most powerful pattern uses the items method, which gives you a key variable and a value variable on every iteration. One line handles both pieces of data. The for loop opens by calling the items method on the student dictionary. Each time it runs, Python unpacks one key value tuple automatically, putting the label into the key variable and the stored data into value. Inside the loop body, print outputs the current key, a colon separator, and the current value. The for space indent tells Python this line belongs inside the loop. The loop ran twice, once per pair, printing each entry on its own line. Thank you so much for watching this tutorial. I hope you found this lesson helpful and easy to understand. If you enjoyed this video, please hit the like button. It really helps the channel grow. Don't forget to subscribe to the channel for more beginner-friendly programming tutorials and helpful tips. Feel free to comment your questions or thoughts below. I love hearing from you, and I try to respond to every comment. And don't forget to hit the bell icon so you get notified whenever I upload new videos. See you in the next lesson.